What will rupees 500 amounts to in 10 years after its deposits in a bank, which pays annual interest rate of 10% compounded annually? So what they're trying to say, you're depositing rupees 500 and after the 10 years, you're just going to withdraw it. So you just need to find the amount after the end of the 10 years. And they also gave us the interest. So this interest is a compound interest. I hope you know the difference between simple interest and compound interest. Yes. So they gave us the compound interest, which is 10% annually. So we are going to find it. So first, you have to note down the amount deposited in the bank at the initial year, which is rupees 500. So you are going to compound this, which means you are going to calculate from first year to 10 year. So at the end of the first year, so you have to multiply this 500 by 1 plus its interest in terms of fraction. Okay. We will be writing like this: 500 times 1 plus interest. What is interest? 10%. So now you will change the 10% in terms of fraction. What is 10% in fraction? It's 10 upon 100. When you simplify, you will have 1 upon 10. So simplify this fraction in terms of decimal. What will happen? You will have 0.1. So 1 plus 0.1 is nothing but it's 1.1. So you just have to multiply this 500 by 1.1. They didn't do it. They are just keeping this as the rate at the end of first year, which means amount end of the first year. So now we are going to calculate for the second year. For calculating the second year, what you will do, instead of substituting it as 500, you will substitute this. This is the formula, like amount 1 plus compound interest. Can you follow? This is the formula. So now when you calculate for the second year, you will substitute the new amount. What is the new amount? This is the new amount. So that's 500 times 1.1. And you will say 1 plus compound interest is 10%. When you convert 10% into fraction, you will have 10 upon 100. When you simplify that, you will have 1 upon 10. When you convert it into fraction, decimal, you will have 0.1. So it is like 500 times 1.1 into 1.1. So
Ma'am,
this
why are we
is
adding? Why are we adding 1?
This is the formula. This is the formula for calculating the amount at the end of a specific year. That is the formula. Because you are just calculating for the next year. So again, you will calculate for the next year. So this will be your new amount. And again, you will add 1 plus the interest. Can you follow it up? So it goes on like that. For end of second year, end of third year, like that, it goes on till 10 years. So if you look at the pattern, you could have seen the repetition of this 1.1. Here it's 1. Here you have twice. Here it's thrice, like that. At the end of the 10 years, you will have 10 times, which could be written as 1.1 the whole power 10. Can you follow this?
Yes.
Could you please scroll to the next question? If arithmetic median and geometric median of roots of a quadratic equations are 8 and 5 respectively, then obtain the quadratic equation. So we do have a formula for arithmetic median. You just have to add 2 terms and you have to divide the terms by 2. So it's a plus b by 2. So that arithmetic median is equal to 8. So a plus b by 2 is equal to 8. When you simplify, you will have a plus b is equal to 16. Considering this as the equation 1. And geometric median, we do have a formula for geometric median as well, which is square root of AB. So square root of AB is equal to 5. So square root of AB is equal to 5. In order to remove the square root, we are just squaring both the sides. So our AB equal to 25. And I hope you are aware of the general form of the quadratic equation. So quadratic equation is nothing but it x square minus x times sum of the roots plus product of the roots is equal to 0. Yes. So it's x square minus x. Sum of the roots is nothing but a plus b. Product of the roots is nothing but ab, because here the roots are a and b, isn't it? So you obtain the sum of the roots from the arithmetic median, and the geometric, you obtain the product of the roots from the geometric median. Can you follow, Radha?
Yes.
Yes. So you just have to replace the sum of the roots as 16 and product of the roots as 25. So now you just have to substitute in the general form of the quadratic form, which is x square minus 16x plus 25. I hope you are able to follow.
Ma'am, how is the root of AB equal to 5?
Because they said geometric mean of roots of the quadratic equation is 5. What is the formula for geometric mean? The formula for the geometric mean is square root of AB. That is how you will find the geometric mean. So here they said it is 5. So which is why you are equating it to 5. See, these are the formula. For arithmetic median, the formula is a plus b by 2. For geometric median, the formula is square root of AB. Can you follow?
Oh, okay. Yes,
Yeah.
yes.
Yes. Well, that's it. That's all about this. What is this? This is exemplar or miscellaneous, Radha?
Ma'am, this is exercise 9.3.
Okay.
Right.
Okay. Could you please share the next exercise?
Yes.
Yeah. Exercise 9.4. Find the sum to n terms of each of the series in the exercise 1 to 7. Fine. So the question number 1, 1 plus 2, 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5. So the series in the combination of the multiplication and addition. So this is the given series. If you look at the pattern of the series, the first element is 1. The second element is 2. First element is 2. The next element is 3. So let's analyze the relationship between the first two elements. The relationship between 1 and 2. If you assume 1 as n, the 2 is nothing but n plus 1. You just have to increase the value by 1 for getting the next term. If you take this 2 and 3, if you assume n as 2, the 3 going to be n plus 1. So that is the pattern, isn't it? So here we can say the term an is equal to n into n plus 1. Can you follow it up?
Yes, ma'am.
So the very first step is observing the series and analyzing it. Okay. So just come to a general format, which is n into n plus 1. The question is to find the sum, isn't it? Sum of n terms. So we do have a formula that sum of n terms is equal to k equal to 1 to k equal to n. A suffix k is equal to summation k equal to 1 to n, and you have to substitute this a suffix k. What is a suffix k? You just have to write this a suffix n in the form of k. It's n into n plus 1, which could be written as k into k plus 1. Can you follow it out? So this is the formula. You're just substituting the value of a suffix k here. Can you follow?
Yes.
So it's k into k plus 1. So you can split them. You can actually split them. I'll show you how. You take the k inside and multiply. What happens? You will k equal to 1 to n, k square plus k. So the summation is common for both the terms. So you can allow, you are allowed to do the distribution. So k equal to 1 to n, k square plus summation k equal to 1 to n, k. All right. So this is the next step. And how can you go further? And this k square summation from 1 to n is nothing but it means sum of the square terms. So summation k equal to 1 to n. Just a second. Summation k equal to 1 to n. K square meaning is sum of the square terms. Sum of the square terms. And we do have a formula for sum of the square terms. You have to by heart this, which is n into n plus 1 into 2n plus 1 divided by 6. Okay, please note it down.
Ma'am, what is this formula for?
This is for sum of the square terms, Radha. What will happen if you
okay.
do the substitution in this? Like you will have 1 square, 2 square, 3 square, 4 square. You will add all those because you have summation symbol here, isn't it? So this is sum of the n terms up to n. So from 1 square to n square, you do it. Can you follow?
Yes.
So this is the formula for sum of the square terms. And summation n equal to 1 to, summation k equal to 1 to n, and you have k here. What does it mean? So you will substitute 1, you will substitute 2, you will substitute 3, you will substitute 4, and so on. It will go up to n. Understood? So this is just sum of n. Yes?
Why are we writing n into n plus 1?
That's what I'm trying to say. I'm just explaining that. So this is nothing but sum of n terms. So the general formula for the sum of n terms is nothing but n into n plus 1 by 2. Can you follow? So this is for sum of the square and this is for sum of the n terms.
Yes.
I'll show you how it all. For example, you assume this as the sum of n terms. You try substituting 1. What happens? It's 1 into 1 plus 1 divided by 2, which means it's 1 into 2 by 2. So you will get 1. Okay. So the very first term, you got 1. So in the same formula, you substitute 2. 2 into 2 plus 1 divided by 2. 2 will get cancelled. Okay. Did I make a mistake? 1 into 1 plus 1 divided by 2 become 1 into 2. Okay. So 2 got cancelled for 3. When you substitute 3, what happens? You will have 3 into 3 plus 1 by 2. So it will be 3 times of 4 by 2. So 3 2s are 6. One minute. I'm getting 1 3 6. When you substitute 1, you got 1. When you substitute 2, 1 plus 2 is 3. And when you substitute, yes. Yes. See that all? When you substitute 1, you got 1. When you substitute 2, you got the result as 3. Okay, you substituted 2, isn't it? So that substitution plus the previous result will give you the new result, which is 3. Okay, so again you substituted 3. When you substitute 3, you got the result as 6. So you add that 3 with this. So 3 plus 3 will be 6. Can you follow?
Yeah.
Yeah. So we'll see what happens if you substitute 4. It's 4 plus 4 plus 1 divided by 2. So you will have 2 into 5, 10. Isn't it? So the previous result is 6. You substituted 4, add with that, and you obtain the result as 10. Can you follow? This is sum of the n series. Can you follow it all? So if you have summation n equal to 1, k equal to 1 to n, k means it's 1 plus 2 plus 3 plus 4 plus 5 plus and so on, it goes on like. So the simplified version of this bigger series is n into n plus 1 by 2. And for the square, it's n into n plus 1 up into 2n plus 1 upon 6. All right. So we are just going to simplify this. How can we simplify? And here you do have n into n plus 1, and here also you do have n into n plus 1. You can take that as common. And in the denominator also you do have 6 and 2. Wait a minute. Okay, that you can simplify it later. So let's take the n into n plus 1 alone as common. What happens? You will have 2n plus 1 plus 1. Okay, they have two different denominators. 1 minute, Radha. Let's rewrite this like this. N into n plus 1. 2n plus 1 divided by 6 can be written as 3 into 2. Plus n into n plus 1 by 2. Okay, so let's take this whole term. Let's take the entire thing. N into n plus 1 divided by 2 as common. So what happens? You will be left with 2n plus 1 by 3 and plus 1. Can you follow this?
Yes.
So you just simplify this by taking LCM. What happens? It's 2n plus 1 plus 3 divided by 3, which is 2n plus 4 whole divided by 3. So just multiply this. Just a second. So just multiply this. It's n into n plus 1 into 2n plus 4. Just take the 2 outside, Radha. So you will have n into n plus 1. Take the 2 outside, you will have n plus 2. Just a second. Sorry for the disturbance. You just take 2 outside from the numerator. You will have 2 times of n plus 2 divided by 2 into 3. So what can you do? You can cancel out the 2 in the numerator and 2 in the denominator. You will have n into n plus 1 into n plus 2 whole divided by 3. So that is your final result. Can you follow?
Yes, ma'am.
Please scroll to the next question. Okay, look at the next question. You have 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5. So you just have n into n plus 1 into n plus 2. So this is your an. If you assume this is n, The next term is increased by 1. The third term is increased by 2. I hope you are able to follow. So if you simplify this, if you perform multiplication between this, take this and this, you will have n square plus n. Just keep this as it is. And again, you perform multiplication between this. So you will have a cubic equation. N square into n would be n cube. N square into 2 will be 2n square. N into n will be n square. And n into 2 will be 2n. So it will be n cube plus 3n square plus 2n. Can you follow?
Yeah.
So the formula is S suffix n is equal to k equal to 1 to n a k. What is that a k? This is a n. So a k means k cube. You just have to write the n in terms of k. 3k square and 2k. So you can split them because addition allows distribution. So you can write it like this: k equal to 1 to n k cube plus summation. You have 3 as a constant, which is multiplication. You can take it outside. It's n equal to 1 to k. I mean n. I'm sorry, I'm getting confusion between k and n. K equal to 1 to n k square plus summation k equal to 1 to n 2k. Again, 2 is a constant. You can take it outside. We'll have this. So this is how you will distribute. Do you have any doubt in this?
No.
So look at the k cube. This is sum of cube terms. So when you substitute k as 1, you will have 1 cube. When you substitute 2, you will have 2 cube, 3 cube, 4 cube, 5 cube, like that it goes up to n cube. So what is the simplification of this? You do have a general form, which is n into n plus 1 by 2 the whole square. For some of the n terms, the formula is n into n plus 1 by 2 simply. There is no power, nothing. But when you cube the terms, when you have sum of cube terms, the final answer is n into n plus 1 by 2 the whole square. I'll show you a proof. For example, 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 60. So this is, it goes like this. Is it? So what happens when you sum? Like 1 plus 8 will be 9, and 9 and 27 will be what? 36. So when you add this and this, you have 100. So it goes like this. So let's see, when you substitute 1, what happens to this? You will have 1 into 1 plus 1 by 2 the whole square, which is 1 into 2 upon 2 the whole square. 2 get cancelled, you will have 1 square, which is 1. So you got the first term. Yes. So try substituting 2. What happens when you substitute 2? You're supposed to get the result as 9, isn't it? Let's see. So it's 2 into 2 plus 1 by 2 the whole square. 2 will get cancelled. You will have 3 square, which is 9. Yes, you got this? 9. So when you substitute 3, you have to get the result as 36. So let's see whether we are getting that or not. So when you substitute 3, what happens? 3 into 3 plus 1 by 2 the whole square. So it's 3 into 4 divided by 2 the whole square. You can cancel this 3 and 4. You will have, wait a minute. So it's 3 into 4 by 2 the whole square, which is 3 into 2 the whole square. 3 2 is 6. 6 square will give you 36. So you have 36. Can you follow Radha?
Ma'am, how do we know when to take that n into n plus 1 divided by 2?
You need to buy
Because
heart.
this is
You need
cube.
to buy heart. When you have cube, when you have a cubic series, you need to buy heart that you have to write it as n into n plus 1 by 2 the whole square. When you have sum of n series, only k, you will write it as n into n plus 1 by 2. when you have square series, you have to write it as n into n plus 1 into 2n plus 1 whole divided by 6. You have to by heart those three series. Only
Yes,
three.
ma'am.
Only three. Okay, I'm just showing you a proof that why you are writing this n into n plus 1 by 2 the whole square for the cube. Can you understand? This is not a part
Yes,
of a
ma'am.
problem. I'm just explaining this. So k cube can be written as n into n plus 1 by 2 the whole square. And you have k square here and 3 is in multiplication. You just write that 3 as it is. And you know the general form of the k square, which is n into n plus 1 into 2n plus 1 upon 6. And similarly, you have 2 times of k. So 2 times of k is nothing, but just keep 2 as it is. And k is nothing, but it's n into n plus 1 by 2. Can you follow? Do you understand this, Rida?
Yeah.
So you can simplify this. This 2 and this 2 will cancel. This 3 and this 6 will cancel. You will have 2 in the denominator, which is this. And this is after the simplification. And now you can go for LCM because here you have 2 and here you have 1. So you can take LCM between them. We do have 2 different denominators. So the LCM would be, I'll write the step here. I think this is wrong. You just have to keep this n into n plus 1 divided by 2 the whole square as it is. And have n into n plus 1 into 2n plus 1 whole divided by 2 when you take LCM plus 2 times of n into n plus 1. So this is how it is. So n into n plus 1 divided by 2 the whole square. Thus, it's n into n plus 1 into n plus 1. 2n into n plus 1, which is 2n square plus 2n divided by 2.
Ma'am, you're just finding the LCM, no? That's why
Yeah,
it's 2n square
yeah.
plus.
We're just
Okay.
doing the LCM. Could you please scroll down a bit? So, 1 minute. Okay, and here. Why they left this square? Okay, you don't look at this. I'll just do it here. So n into n plus 1 the whole square divided by 2. So I can write it like this. I can write the whole square like this. Okay, plus. Okay, I'll just use different color for the next one. I'm writing the square term now. N into n plus 1 into 2n plus 1 divided by 2. And I'll write the simplification of the cube. So you are aware of this after the LCM. So this is after the LCM. So if you look at these two terms, you don't do the multiplication inside, you just keep it as it is. If you look at these two terms, you can take something as common, what it is. Here you have n into n plus 1 And here also you have n into n plus 1. And you have 2 and you have 2. So you can take that n into n plus 1 as common. Okay. So what happens when you take n into n plus 1 divided by 2 as common? This will go this n into n plus 1 by 2 and this n into n plus 1 will also go. So we'll be having this remaining terms n into n plus 1 by 2 plus 2n plus 1 plus you have taken n into n plus 1. You do have this 2 still. So we'll have 2. Can you follow this, Radha?
Yes, ma'am.
So you can simplify this. You have 2n plus 1 plus 2. You just perform addition between 1 and 2, which is 3. So you will have 2n plus 3. So now you take LCM. What happens when you take LCM? This 2n becomes 4n, this 3 becomes 6. So we'll just multiply this by 2, isn't it? So this becomes 4n and this becomes 6. Can you follow, Radha?
Ma'am, like the 2, why is it like the last term that you've written in the step? The 2n into n plus 1. Why is that not there in the next step?
I have taken n into n plus 1 as n into n plus 1 by 2 as common. I have taken it outside.
Oh, okay.
Which is why I striked with the yellow color.
So even the 2 is not there. Oh no, you added 1. Okay.
Yes, yes. 1 minute. Do you want me to show from there?
Ma'am,
Yeah, I'll do it. It's okay. It's okay. You have n into n plus 1 by 2 the whole square, which can be written as n into n plus 1 by 2, n into n plus 1 by 2. I'll write this in the red. N into n plus 1 into 2n plus 1 by 2. In the simplification of cube term and power rule, n into n plus 1. So what I have done, I have taken LCM for this. So when you take LCM, what happens? You just have to multiply this by 2. So you just have to extend this and you will have 2 in the numerator and in the denominator as well. So now if you look at the common terms, what are the common terms? You have n into n plus 1 in the first term, n into n plus 1 in the second term, n into n plus 1 in the third term as well. And you have 2 in the first term. And 2 is common for second and third term, so you can take it out. So you are just taking n into n plus 1 by 2 as common. So you will be left with this and this and this 2. So you will have n into n plus 1 by 2 plus this 2n plus 1 from the second term and the 2 from the third term. Can you follow it all?
yeah.
So now I have just simplified this. 2n plus 1 plus 2 can be written as 2n plus 3. Isn't it? 2n plus 3. Okay. So now you can take LCM. You have 2 here. Just multiply that by 2. So you will have 4n plus 6 divided by 4 divided by 2 when you take LCM. Can you follow?
Yeah.
Can you follow it up? So it's 4n plus 6, 4 divided by 2. So this n into n plus 1 can be written as n square plus n. I'm just multiplying the n inside, which is n square plus n, just to add all of them. So now all of them are addition. So n square plus n plus 4n plus 6, which could be written as n square plus 5n plus 6 divided by 2. And this 2 in this 2, both are in multiplication. So you can take it as 4 outside. You just write it as 4 outside. 2 2s are 4. Can you follow this?
Ma'am, you just multiply the 2, right?
Yeah, I
The
just
2 and
multiplied
the
it.
no.
Yeah.
Yes, ma'am. I got it.
So just a second. So you have this. We are here now. Just factorize this quadratic equation. N square plus 5n plus 6. So when you multiply, you have to get 6. When you add, you have to get 5. So it's 2 3s are 6. 2 plus 3 is 5. Okay. So you have the factors as n plus 2 and n plus 3. That's your factors. So what is the formula? I mean, not the formula. What is the simplification? After this, you have n into n plus 1 by 4. You're just writing that as it is. And this, instead of this quadratic equation, you're just writing the factors, which is n plus 2 into n plus 3. So you can just write this as n into n plus 1 into n plus 2 into n plus 3 all divided by 4. Can you follow?
Yeah.
Can you please look at the past 3 questions? Just one more time.
Yeah.
We have discussed only 2. Okay. Okay, just look at the 2 questions. So before that, I would like to say k equal to 1 to n. K means it is n into n plus 1 by 2. And for cube terms, sum of the cube terms, it is the same, but you have to square it. When you have sum of the square series, it is n into n plus 1 into 2n plus 1 all divided by 6. Okay, please note it down somewhere. You have to by heart.